Video 59, problem number 3. Prove by induction that 3 power n plus 7 power n minus 2 is divisible by 8 for all n greater than or equal to 1, for all integers n greater than or equal to 1. Proof: let P of n be the statement 3 power n plus 7 power n minus 2 is divisible by 8. Then P of 1 is 3 power 1 7 power 1 minus 2 is divisible by 8. P of k is 3 power k plus 7 power k minus 2 is divisible by 8. P of k plus 1 is 3 power k plus 1 plus 7 power k plus 1 minus 2 is divisible by 8. Now basic step. We have to prove P of 1 is true. Now what is P of 1? 3 power 1 7 power 1 minus 2 is equal to 10 minus 2 8, divisible by 8 is divisible by 8. Therefore P of 1 is true. Now we have to go to the induction step. Assume that P of k is true. That is 3 power k plus 7 power k minus 2 is divisible by 8. That is 3 power k plus 7 power k minus 2 divisible by 8 means 8 times an integer, where m is an integer. This is what is known as divisible by 8, means 8 times one integer. This implies 3 power k equal to 8m minus 2 is plus to the other side minus 7 power k minus 7 power k. Minus 7 power k. Minus 7 power k, see equation number 1. Now we want to prove P of k plus 1 is true. For that we have to consider 3 power k plus 1 plus 7 power k plus 1 minus 2, which is equal to, we want to make use of 3 power k. So 3 power k plus 1 is 3 power k into 3 power 1, 7 power k into 7 power 1 minus 2. Substitute the value of 3 power k from equation number 1. 8m plus 2 minus 7 power k into 3 plus 7 into 7 power k minus 2. Multiply 3 inside, 24m plus 6 minus 3 times 7 power k, 7 times 7 power k minus 2. This is 24m plus 6 minus 2 is 4. 7x, this is x, minus 3x plus 4x 4x. This is 24m plus, take 4 common here, 4 into 1 plus 7 power k. You know 7 power k is odd. 7 power k is an odd integer. So 7 multiplied by any number of times odd. So 1 plus 7 power k is even. So even number can be put in the form 2t, where t is an integer. So therefore this is 24m plus 4 into 2t. Now we can take 4 2s are 8, 8 is common, 8 into 3m plus t, divisible by 8. Therefore the conclusion is, therefore p of k plus 1 is true if p of k is true. This is our statement 2. P of 1 is true, we have already proved. 8 is divisible by 8. P of 1 is true. Therefore by 2 states that whenever it is true for k, it is true for the next integer k plus 1. It is true for 1, therefore it is true for the next integer 2. P of 2 is true. P of 2 is true now. Therefore again by 2, when it is true for 2, it is true for 2 plus 1, 3. P of 3 is true, etc. Therefore P of n is true. P of n is true for any integer n greater than or equal to 1. So this completes video 59.